Ignition sequence starts.
Good morning and welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room and the Orbit 2 team of flight controllers who are monitoring station systems and working with the Expedition 60 crew members as they near the end of their work week. Commander Alexei Ovchinin and flight engineers Nick Haig and Christina Cook have an off-duty weekend in store after a busy week of station maintenance and science activities, which included experiments on topics ranging from the perception of time to the cultivation of fresh vegetables.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, fresh food production in space. A healthy, nutritious diet is essential for long-duration exploration missions to the moon and beyond, and scientists are looking at ways to supplement an astronaut's diet with fresh foods grown during flight. The vegetable production system has been testing growing techniques aboard the space station to help meet this need. Current research will be looking at impacts from light quality and fertilizer to nutritional value. Half the crops harvested this week will return to Earth for analysis, with the crew getting some fresh additions to taste test on board. This week, the crew performed the time perception and microgravity investigation. This experiment investigates the perception of time to crew members aboard the space station, something that has not been studied during long-duration spaceflight. Cognitive performance, together with good oculomotor control, eye-hand coordination, spatial orientation, and time perception, is critical for the control of vehicles and other complex systems during human spaceflight. As part of the experiment, astronauts wear a VR headset and have to respond to visual and audio cues with their response time measured by a special program. The results are compared with pre- and post-flight baselines. Evidence from spaceflight research demonstrates that these functions are altered in space and on Earth. This week's question comes from Brianna. She wants to know how landing on the moon in 2024 will impact girls and women around the globe.
I see it as impacting by one major way, and I hope that it is inspiring for all people around the globe. 50 years ago, when we first landed on the moon, not only were the astronauts not featuring women, but also you didn't see women too much in the mission control room. And that's all going to be different this next time around. We're going to have women contributing and being recognized for those contributions in mission control, as the engineers that designed the rockets and the spacecraft, and indeed as the astronauts making the boot prints on the moon.
Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The International Space Station, as a laboratory in space, is designed to be a place where scientists can do research in a variety of disciplines and remove the constant of gravity from their equations in ways they cannot do on Earth. In natural sciences, this is especially useful. For instance, finding out how surface tension and capillary flow can be harnessed to move fluids in more efficient ways. In fact, what might look like somebody just having fun could also help improve systems for moving fluids in microgravity, like, propellants in fuel tanks during space travel. Its position 250 miles above Earth makes the International Space Station a great location for scientific research about this planet. This one, right here. Last summer, there was a new instrument delivered which is gathering information about how plants on Earth sweat, and that provides data to scientists who are monitoring the health of Earth's vegetation.
Sweating can be cool. Presented by Science at NASA. Did you ever notice how the air can seem cooler when you enter a forest? Humans aren't the only living things that sweat to cool off. When trees and plants sweat, they cool themselves and can cool the surrounding air. Through a process called transpiration, water and nutrients are taken up by plant roots from soil and delivered to the stem and leaves as part of photosynthesis. Some of the water drawn up through the roots exits the plants through pores or stomata in its leaves, hence the sweating. As this sweat evaporates, heat is removed from the air, providing a cooling effect. However, if there isn't enough water available or relative humidity gets too high, the stomata close. The plant heats up, ceases to grow, and can eventually die. Healthy plants provide a number of ecosystem services to humans, including food, recreation, and building materials. Plants also impact Earth's global water and carbon cycles, with plant transpiration accounting for around 10% of the moisture in our atmosphere. A new NASA mission called ECOSTRESS, short for Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station, was successfully launched to the International Space Station on June 29, 2018. ECOSTRESS will literally study how plants sweat, providing the most detailed measurements of plant temperatures available from space and helping researchers monitor the health of Earth's vegetation. Your temperature is one of the first things a doctor wants to know when you go for a checkup, says Simon Hook, ECOSTRESS principal investigator from NASA's Jet Propulsion Laboratory. It tells your doctor a lot about your condition. Temperature is an extremely useful indicator for plants too. Temperature data can indicate if a plant is stressed and needs more water before the plant collapses, providing an early warning of a possible drought, explains Hook. ECOSTRESS will be able to measure plant temperatures and therefore plant health over areas as small as an individual field of crops. The International Space Station is well suited for the ECOSTRESS mission. Hook says, most Earth-observing satellites are in a sun-synchronous orbit, so they pass over an area at the same time each day, providing us a daily snapshot of that area. Because of the space station's orbit, ECOSTRESS sees the same spot on Earth every few days at different times of day, so it can track changes throughout a typical day. If, during a hot, dry afternoon, plants stop releasing water to conserve supplies, ECOSTRESS will see a change in temperature compared with previous measurements of the same area. It will detect these kinds of responses in farmers' fields and other ecosystems. Data acquired from ECOSTRESS may, in time, help farmers develop crop watering protocols, give researchers a clearer understanding of the effects of drought, and assist water resource managers in planning effective water use. Its data could also reveal the effects of droughts on natural vegetation. For example, to help identify vulnerable types of trees. Forest managers and ecologists will be able to use this information to make better informed decisions. But that's not all. ECOSTRESS temperature data will be useful in a whole host of ways, says Hook. We'll be able to use the same techniques developed to extract plant temperature to look at other phenomena such as the temperature of volcanoes, urban heat waves, wildfires, coastal currents, lakes, and more. That's a whole story in itself. Want to learn more about this cool mission? No sweat. Just visit science.nasa.gov.
Plant science is one kind of science being done on the International Space Station. Biology research is another, and the MVP, the Multi-Use Variable Gravity Platform, is designed for research involving many different kinds of organisms and cell types. It's especially important in fruit fly research because it will allow researchers to study larger sample sizes than before and to support fly colonies for multiple generations.
We're looking to answer the question, what is the effect of spaceflight on the host here being the fruit fly or Drosophila, and also on a pathogen. So the bacteria actually is one that can infect the fly, very similarly to the way it would infect, for example, a human or any other organism. The genetic makeup of the fruit fly is actually very similar to humans. If you took the human genome and you looked at all the genes that you know are important for function, in that category, in that library of genes, there's 75% similarity between the human genes and the fruit fly genes. In a box this size, thousands of flies can be flown and brought back, so that even if you see an important difference that is small, you can get statistically significant data because you get 3,000 flies or 4,000 flies coming back in a box that size. We have a very nice new piece of hardware. The company TechShot, we've been working together with them for the last few years in developing a very capable piece of hardware.
What's so special about the TechShot MVP is really that there are two internal carousels inside the unit, and each one of them can produce anywhere from 0 to 2 Gs. So it'll be the only payload of its kind in the US segment that can do this. The sample modules themselves do transport to and from the station in the cargo vehicles, but the payload itself, the locker, stays on board the station permanently.
We are interested in human exploration. We want to go to Moon, we want to go to Mars, we want to explore the environment outside of low Earth orbit. And to do that, we need the help of these surrogate model organisms, because once we understand the genes and the pathways, then we know what the countermeasures are that we're working towards.
Along with doing hands-on science on the International Space Station's laboratories, the crew members have been talking directly with students on the ground to share the experience. And some of them have been making fun instructional videos in zero-G. In this installment of the STEMonstration series, Scott Tingle demonstrates the orbit of spacecraft and offers the viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft orbiting Earth, like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
The astronauts and cosmonauts on the International Space Station are spending 6 or so months in an environment where their muscles don't even have to work against the pull of gravity. As a result, they spend a good bit of time exercising to maintain their overall physical fitness. They have a suite of exercise equipment at their disposal, including a treadmill. In this Speedy Time segment, astronaut Jack Fisher runs through the workout they can get on the Combined Operational Load-Bearing External Resistance Treadmill in the station's Tranquility module.
Hello, and welcome back to Speedy Time. Today we're going to figure out how you get some aerobic exercise on the space station. One way is by running. We have a special treadmill. First off, we got to find it. Where is it? It's on the wall. How cool. We first get a heart rate monitor. Next, we get our super duper harness. Next off, we connect in to the T2 itself. These are very important because they simulate load that we would have on Earth, and they pull us to the treadmill. Otherwise, we'd just float off. We make sure that it's calibrated, and we start. A light jog. A little higher pace. We even have a mode called passive. You push it yourself. And then the coolest part of the whole thing is at the end of your workout, it gives you the miles traveled, not just the miles ran. So, using the speed of the space station, 17,500 miles an hour, you can go like, I don't know, 9,000 miles. That's a pretty good run.
At any given time, there are about 300 experiments underway on board the International Space Station. And just before she left the station to return to Earth last month, astronaut Anne McClain shared her perspective on the research that she helped conduct during more than 6 months in space.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask. And so the question really, I think that's important to say is, who are we if we stop exploring? Every day is the intersection of the magical and the technical. Our jobs require a lot of focus, a lot of heads down, detailed work, but there's always moments throughout every day that you step back and you realize, we're working off the planet in microgravity in one of the most unforgiving environments known to mankind. It's really incredible.
Dozens of new scientific experiments are scheduled to travel to the International Space Station aboard the next Dragon cargo ship later this month. The space station provides opportunities for government agencies, private industry, and academic and research institutions to conduct microgravity research, which can lead to the development of new technologies, medical treatments, and products that can improve life on Earth. Dragon cargo ship launch is currently on track for the evening of Sunday, July 21st, one day after the launch of the next Soyuz vehicle carrying these new crew members to the International Space Station. NASA astronaut Drew Morgan, cosmonaut Alexander Skvortsov, and ESA astronaut Luca Parmitano remain targeted to launch from the Baikonur Cosmodrome on Saturday, July 20th, about 11:30 in the morning Houston time. That's 50 years to the day after Apollo astronauts Neil Armstrong and Buzz Aldrin became the first human beings to walk on the moon. Their mission was controlled from right here at the Johnson Space Center in Houston, in a room located one floor up, directly overhead of the space station flight control room you see now. That historic room has undergone a massive restoration to make it look as it did 50 years ago. Have a look at the then and the now. restoration of that room, known as Flight Control Room 2 back in the day, it took years to complete. And I don't mean just to rehabilitate the consoles where the flight controllers sat, but to match the original carpet and the paint and the wallpaper in the room, and match all the furnishings right down to the ashtrays. Here's a slice of what it took to bring history back to life. If you'd like to get another look at any of the stories that we have featured today, you can check us out on YouTube and Facebook, and there are the addresses right there on your NASA TV screen. While you're at either of those places, be sure to look around, because there's lots of other cool stuff that you can find about NASA and America's human spaceflight program. And while you're out there on the internet, check out Houston, We Have a Podcast. That's folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday, and today we start a special series of podcasts on the Apollo 11th anniversary. Gary Jordan goes one-on-one with NASA Administrator Jim Bridenstine, talking about Apollo and about NASA's current efforts to return astronauts to the moon. To stay. Go to nasa.gov/podcasts for today's episode. You can find the full library of all of our podcasts there, and all the other NASA podcasts too, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.